Well, hello and welcome back to Digital++. In this video, I'm going to show you how to build this. Hello.
Hi,
Who are you?
I am Llama, a large language model trained by Meta AI that can understand and respond to human input in a conversational manner. I am here to help answer your questions, provide information, and even chat with you about topics you're interested in.
What is the square root of 749?
The square root of 749 is approximately 27.35.
Can you give me a 40-second introduction for my new YouTube video on my channel Digital++, which is about building an NPC with LLMs and GPTs and speech interface. Everything is built in Unity and it will be available on my GitHub, github.com/digital++. End the video with let's roll up our sleeves and get into the weeds.
Here's a possible 40-second introduction for your YouTube video. Welcome back to Digital++, where technology meets creativity. Today we're rolling up our sleeves and getting into the weeds to build an NPC like no other. Leveraging the power of LLMs and GPTs, we'll craft a speech interface that brings our character to life. And, as always, we're building everything from scratch in Unity. So, grab a cup of your favorite beverage and join me as we dive into the code. The finished project will be available on my GitHub repository /digital++. So, let's get started.
I want to thank Speechify for supporting this video. They reached out to me and offered me free credits to use their product, and with that we can use over 40 English-speaking voices in our text-to-speech module in this video. Speechify can help you make reading easier, but they also have a great API that we can use for our project. Thanks very much. So let's look at the AI components that we want to use to generate what you've seen in the previous video. So large language models, or LLMs, they're generative AI models. And they're trained not just to spit out language, but also to respond in a Q&A style. They take text as input and they generate text as output. So when we want to talk to an LLM, we need to have speech-to-text, or STT. So that module will take our voice, convert that into text, which we then can send into our LLM. For an LLM to talk back, we then need to have text-to-speech, or TTS. When we chain those three together, so first speech-to-text, then an LLM, and then text-to-speech, you virtually have a conversation with AI. And that is speech-driven. If we want to generate anything other than speech, we would need to use another generative AI product. So if you want to, for example, say, I want to have an image of a duck, the system would need to figure that out, and you would need to send the request to Stable Diffusion, for example. For this video, we will limit into speech, but the approach for images, video, etc. will be very similar. With the strawman that we have in this video, you will very easily be able to add these things. So how does that workflow look like? So for speech, and that's for this video, you would speak to Unity. Unity would convert that into audio stream. It would send into the speech to text unit, comes back as text into Unity. Unity then sends it back into another piece of AI, which is an LLM somewhere in the cloud. The LLM responds in text, go back to Unity. Unity then takes that text, sends into a text-to-a-speech module in the cloud somewhere, a cloud service, and that returns an audio stream, which we then send out to our speaker. Here you have the conversation. Let's talk about cloud versus local. AI models have millions of parameters, and even a fully trained AI model will still need a beefy GPU to spit out output. VR rigs have GPUs, but the lack of power and memory to run a high quality AI, and therefore it's really not a good idea to run AI locally, and we really want to use cloud services. Cloud providers have their AI products, and the most common API they provide is the REST API. And REST API is web-based, so you could use Unity web requests to send and receive information. Most of these REST APIs work with JSON. Right? So if you want to send or receive text, most of the time that will be in a JSON format. And there's JSON utilities in Unity as well, which we could leverage for free. Sometimes you have HTTP forms to send and receive data. So that's a little bit different than JSON, but you can figure that out by looking at how the vendor kind of codes and decodes their API requests. The reason why using REST APIs is also a good idea, because it's very universal and flexible. There's such a massive development, and almost every day we have new products. As we speak, Llama 3.1 was released by Meta. You don't want to wait until there's a dedicated API available. The REST API is always immediately available, and you can leverage that and very quickly integrate that into your product. Most APIs are at a cost, unfortunately. There are some free APIs available, at least for prototyping and development purposes, which is what we do. We can leverage those, but you have to search a little bit to find the right API, which is not so limited that you can only ask it 2 or 3 questions, and then you're out of your credits already. So let's look at the LLM API products at a glance. So you have a number of vendors, and there's many more, but I just picked the number of one that I bumped into. So we have OpenAI, they have ChatGPT, that's commercial only, right? So again, ChatGPT may be partially for free, but if you want to talk to the API, you have to pay. Anthropic has Claude, very similar. Now Microsoft has Copilot, which gives you a 2,000 requests per day for free, but you have to provide your credit card details. Google Cloud has Gemini. Now the problem with Gemini is that it doesn't have a free API in the EU, the UK, or Switzerland. At the bottom we have Meta. Meta provides open source. So they have Llama 3, nowadays 3.1. On the GroqCloud, there's a daily limited API that you could use. There may be more services available, but for now, GroqCloud for me seems to be a very good alternative to use for our proof of concept and our prototype. Let's look at speech-to-text API products. Very similar to Llama, a lot of commercial providers have STT, but they have very similar limitations. Now the HuggingFace has an inference API. It has many models, some work, some don't. There's rate limits that apply, but they're fairly good. There's Rapid API. They have an API marketplace. There's a limited number of speech-to-text models available. AWS has Transcribe. From there you can use 5 hours of audio per month, but you would need your credit card. We have GroqCloud. So GroqCloud leverages OpenAI Whisper. It is daily rate limited. The main difference between GroqClouds and other ones is that they use HTTP forms to send audio versus direct streams. That's a bit different, but I've built that one and it does work and it's fairly decent. Microsoft Azure, they have 500,000 characters and 5 hours of audio per month, but again, you need a credit card. And Google Cloud has Chirp. So a little bit about STT API. So there's 2 ways in HTTP to send information to a REST API. And that goes back all the way to the beginning of the internet, right? When the HTTP protocol was created. You have GET and POST. So how do you send microphone data to a REST API? Well, you convert your audio to a stream format and memory. So there you have a WAV file sitting in memory. You want to send that over to the server. Now, if you would use a HTTP GET, what you tell the server is, here's a link to my audio. The server then needs to reach out to you and pull your audio from your laptop. That's not something you want, right? So that's why there's an HTTP post where you say, here server, here is my data, and then you push the stream. So that's why for all these speech-to-text APIs, we have to use HTTPS post and not GET. So text-to-speech products. At the top, Speechify. They have a product called Simba. They have a massive amount of voices, like over 40 just in English alone. American English, British English, but also Indian English, Australian English. And they have many more languages. Their API is paid for. Now HuggingFace has their inference API and they have text-to-speech products, quite a number of them. But the problem with that is it only returns FLAC audio stream. And FLAC is something that Unity can't handle. For that you would need to install an audio library with an extension for FLAC, and I did not get that to work, at least not in a decent amount of time. Rapid API, on their API marketplace, they have a lot of APIs for free. They have rate limited plans, but very usable. Animating the NPC. To make the experience really great is that the NPC moves their lips, right? And they move and they talk. So how do you do that? You have to animate the NPC. animation was done with the animator, and that is by moving the bone structure. Moving the face is done with what they call BlendShapes. And BlendShapes are basically vertex movements and changes. You can kind of switch them from 0 to 1. In the 0 state, the blend shape is off. In 1 state, the blend shape is on. There is fortunately a package available for free, which is called LipSync. In the coding section, you will see where to get it and how to install it. It's a free Unity package you can download from a GitHub. And what it does, it listens to your audio and then synchronizes real-time the blend shapes. And there's a lot of work you can do there to fine-tune it and optimize it. So we're taking just a very basic strawman. We just look at the phonemes like O, A, I, E, U. Now blend shapes have different names across designed products. So if you use Dev Studio, they're called expressions, and expressions turn into morphs, and in a morph you can export. In Blender, it's called shape keys. In Unity, blend shapes are properties of the skin mesh renderer and of mesh components. So you have to look under the skin mesh renderer to see if you have blend shapes. To play audio in Unity, your NPC will need an audio source component. And that's great because the audio source then actually comes from the position where your NPC is located. It also means that if you move away from the NPC or closer to, the audio will get louder or softer. To play an audio source, you need to convert it into an audio clip. That's a special class that Unity has created versions ago. There's a download handler method that can handle multimedia, and you can connect that to a web request. Also note that when you play audio, that's done asynchronously. If you want to execute something after the audio has completed, you will need a coroutine to wait for that. For example, to stop animating the NPC. The great news is that an audio source can immediately use a microphone object to capture audio. And that's something we will need as well. Alright, let's look at a couple of architectural considerations. So as I said before, let's please use REST APIs because it'll avoid vendor lock-in and keep our project really flexible for the volatility on the market. We'll use a Lego block approach, and that is great because that means at every step of the process we can intercept, do some filtering. For now, we will daisy chain all the logical blocks together. I guess over time what we would need is a overarching orchestrator of some kind. Now LLM prompts and outputs are text-based, so we can leverage string-based techniques. And that's pretty cool, right? So it's very simple to create regular expressions. For example, to see, okay, if your input contains the word image or photo, you don't need to send the data to your LLM. You should send the data to a Stable Diffusion. From a design point of view, I said we pick 3 products, and they're all fair use, kind of limited rated products, and we want to use that because we're prototyping. We're not building something professional yet. You would have a microphone object, so you're talking into the microphone. That goes to Unity, generates a WAV file. The WAV file is sent to the REST API. Then it goes to the speech to text, which is in HuggingFace. That sends the text back as a JSON. Then Unity picks that JSON and spits it into the REST API of Llama. Llama then processes that and comes back with a response as text, also in JSON, goes back into Unity, and then we send that to the text-to-speech module in Speechify. We may want to do a little bit of filtering here to get all these weird characters out, like an asterisk, etc. And then Speechify will convert this into an MP3. We convert that MP3 into an audio clip, we play that over the audio source, and while we do that, we animate the NPC with an animator and with blend shapes. This obviously will take time, so the big question is, if you go from speech to response, how much time does it take? You're calling 3 clouds. Is that going to be a massive delay? And the answer is going to be no. So that's the great news. And I had to do that by trial and error. So the next one is, how does the NPC actually know we're asking a question? We need a mechanism to, well, tell the NPC that it should start listening. So as we are building this in VR, and if you're not building this in VR, you have to find another way, we will implement a click-to-talk mechanism with our controllers. So you point your controller to the NPC, you click on your button on your controller, you can start talking. When you release, it will generate the audio and send it into the clouds. So recording of audio is non-blocking, and so is playing. So we do need something like a coroutine to wait for recording to be ready, and that is done by checking whether microphone .is recording is false or true, and we can use a coroutine to do that. And when that's done and confirmed that it's done, we will send the data over to the REST API. So LipSync How do we do that? Well, we will leverage the LipSync package. We can install it from GitHub. You add 2 components to your NPC. You will see that in the coding section. We will need to make sure that we have an FBX that has BlendShapes. I'm not going to show how we do that here, but you can use my FBX that I have on my GitHub. So feel free to download that and try that out. And otherwise you have to be creative and build your own. But you need to have a blend shape for the A, E, I, O, and U to match the phonemes. Secondly, we'll need an animation, which is a talking animation. You can download those from Mixamo. And I'll show that in the build section. You can go to Mixamo, search for the word talking, and you will get a bunch of animations you could use and import that in Unity. We will launch the animation when the audio source is playing is true, and we'll stop it when audio source is playing is false. So very quickly, the structure of the STT component, you'll see it in the build section, so we'll run over this now. For each STT provider, we will have one separate component. All these components must implement a public method called start speaking. There's a record audio, and the STT coroutine creates the Unity web requests. Now the text-to-speech component is a little bit different. Again, you have one component per provider. All components must implement the public method say. There's a play TTS coroutine that converts the input string, which is text, to a JSON, right? Then prepares the Unity web request. And there's an additional coroutine which waits until the talking is finished. And we use that to make sure that we can stop the talking animation of the NPC. All right, so last but not least, what does the LLM component look like? Very similar again. We'll have one component per LLM provider, but Grok in itself already has multiple LLM models you could pick from. So we'll build that into this structure as well, a way to select which model you want to have. API keys. If somebody has your API keys, they can access a service. And if it's a paid service, actually they could hijack your service and use your service for free. So that's not what you want. So for development purposes, we will enter the API keys of the REST API modules in a serialized field private string variable. But if you want to consider building this thing into production, you may want to reconsider that because you don't necessarily want to store your API keys in your application. We could also leverage AI to simplify our API coding. Now the thing with JSON that they are very specific and every vendor will have a little bit of different JSON format. But most of these suppliers have an option to show what the command line would look like if you want to manually generate an API call. Now the great thing about curl is very reasonable. You see that here below, curl, and then you have the HTTPS. So here's your URI of the location of the API. It uses post. And then you have your HTTP headers here. So it expects an application slash JSON. It then expects a header with authorization key. And then it expects with the -D your JSON. And your JSON has a structure like messages, role, content, blah, blah. That can be quite complex. So what you could do is copy paste this whole thing over, go for example here to Anthropic Claude, go open a prompt and say convert this to Unity, and then you copy paste the whole thing in. And it will then spit out all of the classes that you need to decipher the JSON. And we'll heavily use that in our coding because it just saves a lot of time having to figure that out yourselves. All right, so let's start building. Let's start with creating a simple sphere. 3D object, a sphere. Rename that to AI sphere. New materials and make the default material red. It looks like a red sphere. Then let's add a couple of components to the sphere. In the sphere collider, we want to include everything. Add a network object because we are in a multiplayer environment. Again, if you don't want to build a multiplayer environment, you don't need the network object. We will need a client network transform. That's for multiplayer. So we don't need the scaling to be synchronized across the network. We need a rigid body. It doesn't need to be a network rigid body. Turn off gravity, and we want to turn on is kinematic. And then in the constraints, let's turn on all the freezes on both the position and the rotation. And then last but not least, we will add an XR grab interactable, add a collider, and we have a collider here, which is a sphere collider. So let's drag drop that there. And then we want to have interactable events. Well, at the moment, we don't have those yet, but we will create those. When we want to select the sphere with our controllers, we will add a select entered and a select exited event here. We want to add an audio source to our components. Yeah, we want the AI to listen and to speak to us. And there's nothing we need to configure there now. And let's go also to our assets folder and into our scripts folder. Create a new folder called AI. so that all of our AI scripts will be in the AI folder. Start creating empty scripts. So we'll call the first one STT _HF OpenAI. It's a new script. Let's create an add. This will be the script that does the speech to text. We will use the API provider HuggingFace, and the model we'll use will be the OpenAI model. All right, let's add another script. Text to speech, Speechify, Simba audio model. All right, let's create that. Then the last one will be LLM. That will be on GroqCloud. And let's do a create and add. And then last but not least, let's not forget to move them into the AI folder. Everything centrally located. All right, in the next steps, we are going to look at the APIs that we're going to need for our project. And so there are 3 APIs that we'll have a look at. So we're going to look at HuggingFace. HuggingFace has a whole lot of models available. So if you go to huggingface.co, and you'll see all the models that they have available, and you can try those out. What you can also do is say, well, like I want to maybe filter on text to speech, and then you have everything speech related over here, and you can select the model that you need. For now, let's go into the search and search for OpenAI. Let's assume we want to use OpenAI Whisper. Whisper is a speech-to-text API, and this is what it looks like. You can try it out here as well. You can browse a file or record from your browser, and then it'll talk out loud. Well, this is the pre-recorded thing that's available, so let's play that.
Before he had time to answer, a much-encumbered Vera burst into the room with the question, "I say, can I leave these here?"
All right, and you see here at the bottom what it has calculated as a result. I guess you then want to know how can we use that. So there's a deploy button here, and then you can go to the inference API, and then you can switch between the languages. So I prefer curl. This is your URI of the API, so you have to go to this URI. You have to tell it it's a post. Data binary will mean that the input is a binary file. The great news about HuggingFace is that they accept a lot of binaries. Well, here it loads a file, but in our code, which you will see later, we will not provide a file but a stream directly, so you don't need to save it as a file first, and then you need to provide it with your API key. And your API key is an HTTP header which starts with authorization, :, bearer, and then the space, and then you have your HuggingFace key, which obviously for all obvious reasons is not shown here. That's the way you call the API, and then it'll provide you with a response. It will be a text document, which we will see how that works in a second. Copy paste the curl command into a batch file, and let's run that batch file and then see how that works. Go to a command prompt and run that. Okay, so we're in a command prompt. So let's run the STT batch file, and there you see the output. So the output of the text that you just heard is now in our command line here. All right, so how do you read the JSON output? Well, let's ask Copilot, okay? Let's use some AI. So we can say how to decode this JSON output in Unity, right? And then we copy paste the output that we got from our command line. You only need this part here, so let's go back. It provides you with the definition of your data. In this case, it's very simple. It's just only a public string text. Let's go to the next one, our LLM. We want to host that from the GroqCloud. And they have quite a bunch of models already available, including the latest Llama 3.1, which was just recently announced. So that's really great. We can do very similar things here. So you can say hi, and you can push submit. You'll get your response down. And here on the view code button, you can then see what code you need to send into the GroqCloud, which is this model. And then the output will be, again, a JSON format. Very similarly, we can go to our command line, and it'll hopefully spit out the output. There you go. So here's the output of the GroqCloud, which is quite complex. Similar way, you copy paste it into a chatbot and you get a response. What classes you need to define in Unity. So it makes life really easy. And the last one, obviously, I want to talk about Speechify. So Speechify, as I said earlier, is a paid service. If you go to docs.sws.speechify.com, and this will allow you to construct your curl request, and then you can convert that into a Unity. So let's say we want to say hello there. The language string, it's not mandatory. The model is not mandatory, so let's keep that open. The voice ID, that's important, so you have to type a name. Henry is a name. What kind of output should it accept? Do you want to expect an MPEG, an OGG, or ACC? In our case, it would be MPEG. And then you can try it out. And you see the curl request is then created here. So that means with that it works as well. You just have to convert this into a JSON. You can do that again with a Copilot, and then your output will be an MP3, and we can use that. And you'll see in the coding section how that works. Okay, so after this intermezzo, we will go into our text-to-speech code. We'll open the text-to-speech Speechify Simba. We will need the Unity engine networking, and we will need the system. Then we will not use an update function. So let's start with a number of variables. So we will use a serialized field, and we will have a private string, and we'll call it with capitals Speechify API key. So again, we're not going to store this in code. We're going to put this into our inspector. We then want to have a private enum, and I'll call that select voice. In the inspector, I want to be able to select the active voice. Now there's a whole bunch of them, so I'm going to copy paste them in. Then we need another serialized field, select voice, and let's select voice, but with a small letter. Then we do a const string TTS text-to-speech API URI, so that's the unified resource identifier, and I'm going to copy paste that as well to avoid that I'm going to make mistakes. So in a previous section we looked at how to get these type of information from a curl statement. And so the URI is something that we need to provide to our web request. So let's do that. And then we do a private string SF voice. So let's do first the SF voice. What is that going to be? Well, that's the select voice. So let's convert it into a string. And then we want to remove the first characters in the names of the voices. I kind of prefixed all of them with 3 characters, which is the country or the language and an underscore. And then just to be sure, we can do a debug.log, and then we can show which voice we have selected. There we go. All right, so let's save this and let's go have a quick look into our Unity project. So now if you look at the AI sphere, let's open the text-to-speech one, and you see we now have a field for the Speechify key, and we can select all of the voices from Speechify. That is one step done. We will need a coroutine, and so let's start with that. And a coroutine always starts with IEnumerator. We call that play TTS. And the input of that will be a string, and let's call that message. We need to create a serializable item, because this is something that we need to serialize. And then we make a public class text to speech data. What does that look like? Well, it's very simple. It's just a public string input, public string voice ID. Well, we can do much more with Speechify, but for now we'll keep it to the bare minimum. We'll tell us which voice it is and tell us what to talk about. Speechify also provides a language, I think it's called SSML, where you can use HTML-like tags, where you can tell the voice in what tone it needs to speak, if it's angry, if it's happy, how fast, etc. But we'll skip all of that. We can implement that later. And let's put it at the bottom, and we say these are JSON support class. So first of all, we want to do some JSON stuff. We now have text-to-speech data, right? And so we need TTS data. We call that TTS data, and it needs to be a new text-to-speech. So yeah, we need to allocate some memory for this thing. TTS data dot, well, we have an input and we have the other. So the input will be message, and the TTS data dot voice ID is going to be the ID that we selected, and that should be as a voice. That's a global variable. Now there's one thing with the input here, is that the output that an LLM can generate can contain all kind of non-readable characters. So like asterisks and kind of semicolon and colon, and we could, for example, create a very simple function here which we could call simple clean text, and that could be a function of a string. We will return a string, so that's what we will do. Return result, and what it will do, it will take the input message, and then we say for then message, for each letter we're going to see what it is. So let's do a switch, and I'll copy paste this in. I'm not going to into the details here, but you could probably read this out pretty quickly, that if it's a plus, we want to call out a plus. If it's a colon, we want to enter a space so that it waits for a second, etc. So at least it prevents us getting ugly error messages. Oh, there you go, my bad. All right, and so the result should go over here. And we need another one to close this off. Okay. Instead of now assigning the TTS data input to message, we will actually do a simple clean text of message so that the message is being filtered. All right. So now let's set up a Unity web request. And for that, we call that request. And that is a new Unity web request. And what are we going to provide? Well, the text-to-speech API URI, and we are going to tell this is a post message. And then we're going to tell the request what the upload handler is going to be. So what are we going to upload? Well, let's do a new upload handler. And what are we going to give that? Well, we have system.text, and it needs to be encoded, and then it needs to be a UTF-8 get bytes of, well, our JSON prompt. And we don't have a JSON prompt yet. Let's generate that first. When the voice ID is done, let's create a JSON prompt. So let's create a string called JSON prompt. We're going to convert our text-to-speech data with the JSON utility to JSON, and that's going to be the TTS data. So with that, the text-to-speech data structure is converted into a JSON file by the JSON utility, and the JSON prompt is being pushed into the request upload handler. And I made a mistake here. It needs to be upload handler raw. Okay, so the request.download handler, what is that going to look like? Well, we're going to send a JSON. We're going to get an MPEG file back. We're going to tell Speechify that we want an MPEG file back. Fortunately, there is a standard mechanism in place called a download handler audio clip. And what is it then? Well, it's a TTS API URI, and you need to get an audio type dot, and well, we know to have an MPEG, so let's say this is going to be an MPEG file. Then we need to do some HTTP header work, and we're going to say, well, request.set request header, and the content type needs to be application JSON. Then we do another set request header. We're going to tell Speechify that we want to receive an MPEG file. And last but not least, we want to tell the system what our API key is, authorization Speechify API key. So now all of that is done. We're ready to send the request to Speechify. Let's do a yield return request.send web request. And so we're going to wait until the web request comes back, and then we're going to look at what is the request result. If that is Unity web request result.success, then we want to do something. If not, then we are going to debug.log TTS API request failed, and we know which module failed. Inform the user on what error has been casted by the system. So now here, let's create a little bit more space. We create an audio clip, but it's a download handler, but we want to have an audio clip part of it. And then we want to get the get content request. So now we have our MPEG-3 data decoded into our audio clip. And so now what we need to do is get component of audio source. And then we want to play our audio, but we only want to do it with a one shot. So play one shot, play our clip. And then we're done, but then unfortunately, this is played asynchronously. So we need another mechanism to wait until we're 100% sure that the talking is finished before we could do anything else. Like, for example, stop the animation. I enumerate Tor, and we'll call it wait for talking finished while get component audio source dot is playing yield return null. And we'll come back to that in a bit. You want to do a start coroutine, and you want to call the wait for talking finished. Done. What we could do now is see if we can make this work. The way to do this would be to do a start coroutine of play TTS. Well, that's not so friendly for any future users. So let's create a public method that people can use. Say string text input start coroutine of the play TTS of the text input. So what we want to do now for debugging purposes, say this is digital plus plus. Okay, so to try this out, let's first select a voice. Let's say US Christie. And then you need to provide your Speechify API key. So I'm not going to show that here. And then we're going to run this code. So
this is digital plus plus.
All right. So it seems that it works. It actually means that our first component, which is the text-to-speech interface, is all done. Great. Let's go on to the next one, okay? So now we want to go to the LLM, and we're going to use GroqCloud. So we say these are the LLM classes. In the view code, you would need to send a class, which we'll call request body, which consists of a field messages and a field model. So let's create that first. And that needs to be system.serializable because we need to send this out to the API. So there you go. So we created a request body. A message, if you look at the GroqCloud, it contains something like role and content. All right, so let's create that first then. So we have a class message, which has a string role and a string content. Right, now the output was all goo of stuff. So I am going to copy paste those in, and literally I got those from a chatbot. This is what I'm going to put in. JSON stuff done. Now let's go back to the top. We want to have a private string, which is an API key. Serialized field, private string, API key. And we need a string for the URI. So very similar to the voices in the text-to-speech, we now need to have a drop-down that can allow us to select any of these models that Groq has available. Now we need to do a little bit of tricks here because all of these names here, like Gemma, have a dash in between and you can't put that in. So we need to replace that. So under that serialized field, private LLM model, selected model, we want to have a string that contains the content of what we selected. Selected LLM string. And then let's also add another string that we'll need later. Private string LLM result that contains the output of the LLM, and we have to put in something. So for now I've done waiting, so we know that we haven't received anything yet. So let's go to the start function now. And so the first thing we want to do in the start function is to unpick which model we've selected. Selected LLM string, that is selected model dot to string. We're going to replace all the underscores with a minus because it needs to be a minus. And we're going to also replace x to a dot. Debug.log plus selected LLM string. And now in the LLM Groq you have a drop-down list. You can enter your API key again and you can now select each of your models. So we now need to find a way, how do we connect to our text-to-speech component? And as I said earlier, in this simplified version, we're going to simply daisy chain these components. TTS Simba, TTS SF Simba. Then we need another serialized field. LLMs can be very verbose. So you ask a simple question, you get a 3-minute answer. Well, the great thing is prompts are all string-based, right? So we can just tell the system to be verbose. So let's create a bool, short response. So let's remove the update function for now. We don't need that. Private IEnumerate store. And with this time we call it talk to LLM. And we want to have input message. We want to create our JSON body, right? So request body is new request body. The messages, and we know this is an array, so we need to create a new message. And what needs to go in there? Well, we need to tell it it's a new message. Role your user, and yeah, we want to enter the message. Request body dot model. Which model is it? Well, the one we selected LLM string. Okay, then we create a JSON request body again. JSON utility dot to JSON. And we're going to tell this is a request body. And then we tell the LLM results field that it is awaiting Unity web request. Request is new Unity web request API post. We need to have a byte array. Body raw is system.text.encoding UTF-8 get bytes. That needs to be coming from the JSON request body. The request.upload handler. Upload handler raw, body raw, and then the download handler in this case is, but it's a JSON file again. It would be download handler we cast, and now we say download handler buffer. With the Simba on the download handler, we got a audio clip. In this case, we are just getting the raw buffer. Then let's add request headers. Request.set request header. What header do we need to set? Well, obviously we want to tell the system that it needs authorization bearer with a space plus API key. Then, because this is a coroutine, we're going to say, well, yield return until the rep request is done. Then we're going to copy paste if the result is success, else debug and log error message, and we can do the same as there. Debug log failed else, and then this is an LLM API request failed. So let's say the response text. That's the only thing we're interested in here, right? Let's pull that out of the download handler.text, because this is a bunch of JSON data still. All this goo that comes out of Groq. So the GroqCloud response, GroqCS is JSON utility that from JSON, GroqCloud response text. LLM result is going to be CS dot. Well, there's a bunch of choices, right? We will only have one response, not multiple, and we need to have the message obviously and the content of that field where the actual response is. And now what we also can do is debug.log LLM result. So you get, at least in your debug, a written message that it has returned. Now there's one tiny bit. We still need to find a way to call this function, right? And very similar to the text-to-speech, we don't want to tell people to use a start coroutine. So let's do a public void text to LLM, and you send a string message in. What it does nothing else than a start coroutine talk to LLM function. And what are we going to send? So short response. If that's true, then you need to add something to message. Let's keep it short. If not, then we'll just pass on the message. String, and there you go. And then to test it for now, let's do a text to LLM. Hello. And let's also go to Simba, remove the debug message here. So the first thing we need to do here is that we need to tell LLM Grok that it has to use Simba. Then we need to agree which model we use. So let's take the top one for now. And we need to add the API key, which obviously, again, I won't show here. Let's see whether this works, right? So let's run this thing and let's have a look at our debug log. And yeah, you see, it responds, hello, it's nice to meet you. Is there something I can help you with? All right. The cherry on the cake here in this section is obviously tell it to connect its output to the TTS Simba. So where do we do that? Well, in the text to LLM function, once we have the result logged, we obviously now need to call text to speech. So what we could do is say if TTS Simba, then we want to call TTS Simba dot say LLM result. Keep the fingers crossed.
Hello, it's nice to meet you. Is there something I can help you with, or would you like to chat?
So that is now working as well. So we now have created an LLM module. We've created our text-to-speech module. The next step will be to build our speech-to-text module. So let's start doing that now. Very similar to the ones before. So I'm going to skip a little bit over all the detailed steps, and I'll do more copy paste because you probably get how this works now, right? So we'll start with a section on our variables. So obviously we need our API key again. We're going to use the HuggingFace Inference API. I'm going to use the Whisper Tiny. I need some stream. We are going to convert our microphone audio from an array of floats into a WAV file. I don't think we need to start an update, so let's remove those. We're going to do the coroutine first, and this coroutine is to record audio, right? Because one of the things we need to do is we record audio and send it into a WAV file. All right, and that will have a clip as an input. While the microphone dot is recording, and we will provide null as the default microphone. As long as that's not ready, we will return null. Audio source AUD, get component, and we do know we have an audio source, right? Because we just added that all the way at the beginning. How do we create a WAV file? I'm just going to copy paste the code in. If you want that code, please go to my GitHub page. This comes from a forum somewhere. I call it convert clip to WAV. It inputs the audio clip, which comes from your microphone, and then boosts it out to a stream. So once this is done, we do a convert clip to WAV of the audio file and .clip. Because this is a coroutine, the coroutine is not able to return a parameter. So what I'm using is a global variable called stream. So now we can start a coroutine to run speech to text. So let's start with an IEnumerator, speech to text, and it has no inputs because it reads from the memory stream. STT is very similar like the other components that we built before. So we're going to create a speech to text data. That's your JSON handler. All right, so let's put that in here. For HuggingFace, input is really simple, just string text. We set up the Unity web request again. It needs networking. So let's look at the request.upload handler. What does the upload handler need to do? Well, it needs to send your stream. Upload handler raw stream.getBuffer. And so you push the WAV stream into your upload handler. And then the download handler is very similar like before. I'm going to copy paste that here. Now we're going to look at the headers. So the request, it needs two headers, a content type application JSON, and it needs an authorization, which is bearer, space, and then the HuggingFace Inference API key that we defined at the top. So we can start sending yield return request dot send web request. If the result is positive, then great. If not, then we will cast a debug error. STT API request failed. Oh, okay. We get the result out of the download handler because it is text, the response from that text out of the JSON, and then we do a debug.log, STT response.text. The great thing is we can now send it to our LLM. If we have LLM Grok, if that's defined, let's send it to .text to LLM, STT response.text. And so now we've connected the output of our module to our LLM. So public void start speaking. So the stream is a new memory stream. Audio source is get component on of an audio source. We do a debug.log and we say start recording. The AOD.clip is a microphone.start from the default microphone, which is null. No, we're not going to loop. And the length in seconds, now let's say 30 seconds could be enough. And the frequency, well, let's not do it to high frequency. It's just a lot of memory. So let's say 11.0.25. And now we want to start with the coroutine calling the record audio. Well, with the audio.clip. Let's do a quick public void start. And we'll just say start speaking. That means that we start the program and immediately we need to talk, and then hopefully it should respond to us. Let's remove the debug message in our LLM Grok. And just to be sure, for now, let's make the time to record only 10 seconds. But then the next thing we need to do is we need to tell speech to text module which LLM it needs to use. So right, let's connect it from there. And we need to add the API key. So let's give it a try. In the console here, you should then see the output of our speech to text. What is the square root of 22?
The square root of 22 is approximately 4.69.
All right, awesome. So this is working as well. The next step is that we replace this AI sphere with a more realistic NPC and avatar. But before we can do that, we want to add a few more things to our script. So we can leverage our speech to text event-driven and not from the start of the program. So let's remove the start function. We don't need that. And let's add two event handlers. Public void select event handler, enter event args. And we also need a public void select exit event handler. And that is a select exit event args. When you select the NPC, it needs to start speaking, right? So that's quite simple. Let's do start speaking. When you stop selecting, what should it do? Well, it should stop the microphones. Microphone.end, and it should be the default microphone. Reminds me that we need to change back the time here to 30 seconds. Again, it'll give you maximum 30 seconds to talk. The first thing we will do is we go to our prefabs folder and we create a new folder and we'll call that NPC, and we'll create a folder called NPCF, like from the female NPC. So I've already copy pasted in a 3D model of a person, so adding it here, and all the textures that come with the person as well. So I'm not going to spend too much time on how you generate this, but there's multiple tools for you can download them, but you can also generate these models. So let's first do a quick import as well, right? So this should be an animation type humanoid. Avatar definition will be created from this model. So let's do that first. Now let's go to material creation mode is standard legacy, and we will use embedded materials and we will extract the materials. What that will do is it will save the materials into this folder. So now we have all these materials here. Let's save this well. And we can, if we want to, can update and fine tune these a little bit. And let's turn it 180 degrees. And you see the eyes, for example, aren't that great. We can make a couple of fine tunes. So I'm going to do that in fast forward mode now. So I'll stop the recording and I'll come back when the updates are done. So this person is now going to be our new NPCF. And so this is going to be a prefab, and let's save this. So now it is a prefab variant into that folder. One thing I want to do with this is we want to start using the LipSync. And for example, you see the BlendShapes here. So you can move the O and you see the mouth is moving. You also need to move the mouth shape and move the teeth as well. So there's some synchronization needed to make sure that all these BlendShapes move at the same pace. And we'll go into that in a little bit. Let's remove the NPCF from our main scene. Let's move the AI spheres into our NPCs folder. So now we have the AI sphere as a prefab and we can remove it. So let's generate a empty game object and we call it NPCF, right? So this will be our future NPC. Let's put the NPCF, original NPCF, in the main field, and let's do a right click and we will do a prefab unpack. So now let's move everything, copy paste that over and copy paste it in our new NPCF. All of it we need to move as a parent. Let's remove NPCF1. And now let's move all these components under Genesis 9. So now we have an NPCF and we have it on everything under a central Genesis 9 game object. First of all, the position should go to 0, 0, 0. And let's change the rotation to 180. And we'll bring it a little bit closer. For the time being, we could put the AI sphere back. We need to add all the same components to this NPCF. So let's go to the NPCF. We need to add a network object. We need to add a client network transform because we want this thing to be visible over the whole network, and remove the XYZ scale again. We want to add a capsule collider. We want it to move to 0.9 and the height needs to be 1.5 there, and the radius can be a bit smaller, 0.3. Include layers everything, an audio source. Right, because we want to talk to the thing. Rigid body, use gravity off, is kinematic on, and we want to freeze all the positions. XR grab interactable. Collider, we need to add a collider. In this case, it's the capsule collider. And then in the interactable events, we need to select entered and select exit. And now in this case, we need to bring NPCF and set NPCF. Yeah, then we're going to add here first the STT component. And now we go to the so now we go to the STT Edge OpenAI, and we take the select enter, and then we take the STT HF OpenAI select exit event handler. All right, so now we have the event handlers connected to our grab interactable. Let's add the Grok LLM, and so let's add the LLM in there. We need to have the TTS, so let's daisy chain this thing. Let's move the TTS into there. And obviously we need to add our API keys, and let's select the Llama 38B, which is good enough for now. So we have now our AI components added. What we then want to do is we need LipSync capabilities. So this is the project from Acomi. Let's go to releases, and so this is the latest release, and we want to have the Unity package here. So let's download this, and then we drag drop the file here, and we import. Add component LipSync, and we need to add a component called LipSync BlendShape. Now for the LipSync, we need to create a new list, and so as a game object we put in the NPCF. So let's drag drop that in here, and for the function we go to LipSync BlendShape on LipSync update, and we need to add a profile. So let's select one. We want to have the female profile. And on the blend shape, which one we want to connect to? Well, we need to have the Genesis 9 shape in our situation. And then we want to add a bunch of phonemes. We have an A, an I, an E, an O, and an U. And you can add more if you want. So if you want to, you could really fine tune this and make this much more natural, but we'll do it quick and dirty here. So we do 1, 2, 3, 4, 5, 6, because you need to have one empty one. So that's the default one. Phoneme is dash, and this phoneme is A, O. It needs to be exactly the same name as the phonemes you use. How do I remove this? At the blend shape, well, great. So we have Genesis 9A, that's the blend shape. We have for O, we have an O blend shape. We have an I for a blend shape. So let's connect that here. An E, same here. The U, we have the U blend shape, and we have the none, we'll use that. So that means all the lip sync stuff to be done. And again, I'm going through this in warp speed. There is a great video about this, which I will post in the comments below. So if you want to see how this works in detail, you could follow this specific video. So I think I have all the objects here now. Let's have a look. 3 AI scripts, the lip sync, and what I need to have obviously is an animator, because I want to also do some animations. Let's open that one. And so the avatar will be the NPCF avatar, and the controller, well, let's create that one. So let's go to our anim folder and let's create a new animation controller, and we'll call this NPCF animator. So let's double click that, and now we need to import obviously some animations on the Mixamo side. So let's have a look there. So let's look at an idle animation. Yeah, that could work. So let's download this. We don't want the skin there, so I'll download it. And let's have a talking as well. Talking animation. I think I have this. Yeah, we could use this one. Download it. without skin. So let's go back to Unity. And in our animation folder, let's import these files. We have the idle and the talking, so we'll drag drop them in here. For the idle, let's go into rig to make this humanoid, otherwise it won't work. Let's apply. Same for talking, humanoid. Add the idle into our animator, rename that into idle. Move the talking into our animator, call that talking. On the idle animation, it should be looping time, so we want to continue to loop that. What we also want to do is that we bake the root transforms into the pose. We apply it. The same for is talkings. Then we create some transitions. We create a transition back. Now create a new parameter. So let's create a new bool is talking. You move from idle to is talking on the condition that is talking is true. And then we move back from is talking to idle on the condition that is talking false. We need to switch off has exit time, and we need to do the same for that one. One typical issue that one tends to forget. Great. So the animator is done. So let's have a look. We have the animator and the animation controller we now need to add, and that's the NPC animator. And I think that's all done. Do we need to add the add root motion? Let me have a look. Yeah, let's apply root motion as well. So let's try this out and let's run this thing, see what it does. You see something funny is that the avatar is looking like it lost it a little bit. To fix that, we need to change something in the avatar description. Go into prefabs, NPCs, and NPCF, select the NPCF here. The rig, select the avatar configure, head, jaw, change that to none. So we go back here, click on this small arrow. Yeah, we apply. And now let's start. All right, that looks much better. Go to the animator, because this is the idle state. And let's go into the animator and switch on is talking. You see it's now talking. Great. And it should continue to talk. Okay, great. How do we control the talking animation? So let's build that into our code. The first thing we're going to do is remove the AI sphere. Now we want to control the animations from the text to speech, because that's when the moment when we know where we have speech or not. So we have the SF voice. Let's add an animator. Animator, avatar animator. First of all, in the start function, we need to get a link to the animator. At the beginning of start, try to get a link to the animator. At the moment that we know that we got a response from the web request, because that's the moment when the audio should start. Before the audio clip, okay, avatar animator dot setBool is talking true. We need to stop talking. You know, we have wait for talking finished. We know that after the yield return, audio is playing is done. So now we can do avatar animator dot setBool is talking false. And now I think we should be good to go to try to test out the whole thing. Before we do that, let's make sure that in your STT, your LLM, and your TTS scripts, you have your API keys entered. And also select the right voice that you want for your avatar. So in this case, I selected Christy. Last but not least, there's a risk that you, with your controllers, could grab the avatar. So you need to turn off the track position, the track rotation, and throw on detach. So let's now see if we can run this, okay? All right, let's walk up to the avatar. Looks pretty good. Let's click and say, what is the square root of 25?
The square root of 25 is 5.
So we'll need to start on an update in this function. Let's first start with the variables. All of the game objects, I want to, instead of hard coding it, want to drag drop them in the inspector. So let's create a serialized field, shape of the main object, the mouth, the brows, and the lashes, because those are the ones I want to animate together with the main object. For those, we need to get the skin mesh renderer. We also want to get the meshes. So we have the game objects, we have the skin mesh renderers of these game objects, and we have the meshes. Finally, I want to make sure that we have connection to the animator here, because we need to do something with the animator as well. The animator, that is the get component animator. So we will find the skin mesh render first. Gen 9 shape, get component, skin mesh render, mouth, skin mesh renderer, Gen 9 mouth dot get component, skin mesh renderer. Same for the brows and the lashes. Fast forward that a little bit, and we want to figure out what the mesh of that is. Gen 9 mesh dot shared mesh, and we want to do the same for all the other three. Copy paste those in to speed it up. So now what do we do with it? Well, we use that in update, and in every update cycle we want to make sure that all of the blend shape data from the Genesis 9 shape synchronized with the mouth, the brow, and the lash. We want to first check in the animator if the animator is talking, because otherwise it doesn't make any sense to synchronize. Well, int I is 0, I smaller than gen9 shape mesh blend shape count. That's why we need the mesh, so we know how many blend shapes are in. Float v, gen9 shape SMR, get blend shape weight, synchronize the mouth SMR, set the blend shape weight of the index, right? And then the brow, and then the lash will do the same. So that should be it. So before we run this, we obviously need to move these shapes into the inspector. So the main gen shape, let's drag, drop that there. The mouth is this one, brows, and the lashes, eyelashes there. Get this to work. Let's push play and see what it does. Hello.
Hello, how can I help you today?
What is the square root of 200?
The square root of 200 is approximately 14.14.
So we see that when the NPC speaks, the mouth movements are way too exaggerated. So we can fix that. If we go into the LipSync blend shape grip, you see that the max weight here is 1. So let's move that to 0.4-ish for each of those blend shapes. And then let's see what the result will be. So let's give it a try, see how it works. Who are you?
I am an AI assistant. I am a computer program designed to understand and respond to human language, here to help answer your questions and provide information on a wide range of topics.
Are you an LLM?
Yes, I am a large language model LLM.
What model LLM are you?
A concise question. LMRU stands for least recently used.
No. What LLM are you?
I am Llama, a large language model developed by Meta AI.
Which model version are you?
I am an AI, specifically a transformer model, version 5 or more formally, GPT 4-second space architecture is Llama. Updated version based on Instruct series fine-tuned, called V, is likely considered more refined. Iterative since and onwards also could do knowledge dating by summer 2023.
How many parameters do you have?
I have over 175 billion parameters.
Thank you.
You're welcome.
And that rolls up this how-to video on building an intelligent NPC in Unity. I used the BAM construct to render the NPC in virtual reality, but you could just as well make a WebGL or mobile desktop application yourself. I hope you appreciated and enjoyed this video, and maybe I sparked some enthusiasm to pull the repository and try it out yourself, or even help build out new cool capabilities in this smart NPC branch. Happy to hear your ideas, and please feel free to reach out to me if you have any further questions or any problems or issues. Bye bye for now, and hope to see you next time.